We are continuing with similar triangles, and there are going to be 4 things that we're going to be doing in problem number 13. What I'd like you to realize, whenever you guys understand that these are similar, if you guys see this triangle here and this triangle here, that's stating that N to J and M to K, these are parallel. That's pretty important. That means that they are going in the exact same direction. What I want you to do right now, if you haven't done this already, you probably haven't, it's okay. I want you to understand, we have what's called a large triangle. And inside of this triangle, we have a smaller version of this triangle that is similar. So what you're going to notice as we do...
Can you draw that?
Yeah. I'm going to make a large triangle to the best of my... You don't have to use blue or green. I'm just using blue and green. So I'm going to make a large triangle right here. And I'm going to label the large triangle. This is J. This is N. And this is L. And then I'm going to make a smaller triangle just underneath it. Alright. And I'm going to label this smaller triangle K, M, L. So I'm just drawing these side by side, which makes things a heck of a lot easier when you're trying to compare sides and lengths. So please do this right now and make those labels. Now that we have these drawn, we're going to start labeling things. So here we go. We're going to first label the distance from J all the way to L, and you're going to notice I'm going to make that distance 24. We're going to label the distance from J to N, which is 18. All right? Now this is where it's going to get a little tricky. Hopefully you guys understand. If this is 8, from right here to right here, if that's 8, then what does K to L have to be? 16. That's right, because 8 plus 16 is 24. So right here, put a 16. Now, the distance from M to L is pretty self-explanatory. The distance from M to L is 6x plus 2. The tricky one is the distance from N all the way to L. So we have to add this to this. Go ahead.
7x plus 7.
That's right. 7x plus 7. So if we add these together, we add the x's together, we get 7x. We add the 5 and the 2 together, we get 7. Now we have triangles we can actually compare. Now that I have everything labeled, now what we're going to do is we're going to find our similarity statement. Here we go. Step 1, our similarity statement. I'm going to start right here at J. So triangle J. Then I'm going to just travel to L. And then I'm going to travel to N. Now that's not the only way to go, but that's the way I'm doing it. I'm going from J to L to N. But if I go from J to L to N, that means I have to do the exact same pattern in the other triangle. KLN. There we go. So this is a correct similarity statement. Now, if you didn't write this, all right, you got to make sure that your order should still be the same as mine. I can't go from J to L to M and then say, I'm going to go from K. I just feel like going to N to L. It's got to be KLM. So that's step 1. Step 2, we're going to solve for x. So I'm going to show you what I'd like you to compare. We are going to compare this right here over this to this side over this side. So we're going to compare right now, I'm going to go ahead and write it down right here, 7x plus 7 over 24. So this one over this one, we're going to compare it to 6x plus 2 over 16. Now, you guys don't have to do this on your paper, but basically what I'm looking at is basically this proportion sets itself up. This over this equals this over this. So I'm just looking at a way to set up. If you're wondering if that's people yawning, yeah, those are highly motivated students that are working right now. So, what I want you to do right now is, to the best of your ability, cross, multiply, and to your best of your ability, cross, multiply, and solve for x. There we go. Use your cross products. I'm going to write your cross products. You guys do the best you can to solve it on your own. So 16 times 7x plus 7 equals 24 times 6x plus 2. Go ahead, work it out to the best of your ability. Okay, what I was hoping that you would do was multiply the 16 times the 7x and the 16 times the 7. So what is 16 times 7x? What did y'all get? 112. So what I want you to write right here, write 112x plus 112 equal, hold on. And then we're going to do 24 times 6x and 24 times a 2. Now what did you get for 24 times 6?
144.
So we're going to write 144x plus 24 times 2, which is 48. This right here, some of you were adding things that you were not allowed to add. That's okay, as long as you understand. The x's cannot be added to this because these are not like terms. We have to solve for x, okay? So if we have to solve for x, that means we have to get all the x's to one side and all the numbers to the other side. So where do I have the most positive values for x? On the left or on the right? On the right. So right here. You guys see this? So what I'm going to do first is I'm going to say, you know what? I'm going to establish where all of the x's are going to end up. Now, why did I choose to subtract 112x? Because that's a positive, so I have to do a negative. All right? Right now, that's the very first thing that I want you to do. If you haven't done it, do it right now. 4 minus 2 is 2. 4 minus 1 is 3. So now you should have a total of 32 x's. If I have all my x's over here, that means I have to get all of my numbers on the left-hand side. So I need you to take away a 48 on this side and take away a 48 on this side. So I'm going to have to borrow. 12 minus 8 is 4. 10 minus 4 is 6. So what do we have left now? We have a 64 equals what?
32x.
32x.
You're going to divide by 32.
At this point, what have we done? We've put all of our numbers on the left-hand side and all of our variables on the right-hand side. Whenever you're solving for an equation, you've got to have all the variables on one side and all the numbers on the other. There's only two things you're doing. You're either adding or you're subtracting. That's it. You're either adding or subtracting. Like terms. Things that are alike. So you're right. At this point, you are going to divide both sides by 32. And x is equal to 2. That's what x is equal to. So what I'm going to do right now, I'm going to take that value right there that we just did, solving for x, and I'm going to bring it right up here, and I'm going to write x equals 2. Yep, I'll go back there. Step number 3. We have two things we need to find. One thing we need to find is what's called the scale factor. Another thing that we need to find is the distance to two legs. Right here we have N to L and N to L. So right now I'm going to label those. Which ones? N to L and N to L. So we need to find those two segments. So what am I going to do with this number 2? What am I going to do with it? I'm going to plug it in. I'm going to put a little arrow here, which means I need to plug it in there. I'm going to plug it in right here. So 7 times 2. I'm going to write it right up here. 7 times 2 plus an additional 7. 7 times 2 is 14, plus 7. That means this distance right here is 21. 21. M to L. I'm going to go and solve that right here for you. 6 times 2 plus 2. 6 times 2 is 12. 12 plus 2 is 14. So right here, from the distance from N to L, that's going to be 14. So that's done. Last step, enlargement, reduction. So right now, we could compare this side, the 14, to the 21. We could compare the 24 to the 16. It doesn't matter. You're going to get the same answer. So right now, watch this. We're going to go over here, and I'm going to show you how to compare. I'm going to go right here, so hopefully you're watching. I'm going to go 24 to 16. Or I'm going to go 16 to 24. Now, what are these both divisible by? 2. What else? 8. Very good. They're both divisible by 8. So what's 24 divided by 8? 3. What's 16 divided by 8? 2. So if this reduces to 3 over 2, this one is going to reduce to 2 over 3. Your enlargement scale factor is a 3 over 2. Your reduction scale factor is 2 over 3. Your final answer is all of this right here. Those are the 4 things that I'm looking for you to be able to find on all of the other problems. This is the last example I'm doing for similar triangles.